All right, guys, Mr. Jenkins back here with second lesson of chapter 4. So section 242. This is about more about graphing parabolas. Last lesson, if you recall, was about equations being in vertex form, that kind of funky looking x minus h squared plus k form. But this one is in standard form, right? So this is more like what you would see, hence the name standard form. So you know what you would see on more of a normal problem going forward. All right, so standard form is that. So as you can see, so it's ax squared plus bx plus c. That's in standard form. Which, by the way, we can convert this one vertex form to standard form, but we can cross that bridge when we get there. So a is the coefficient of the x squared variable, b is the coefficient of x, and c is your constant. So example 1 wants us to graph the equation y equals negative x squared plus 2x plus 1. All right, and wants us to just use our graphing calculator. So I will go ahead and do that. So I'm going to hit y equals, clear out whatever is there, and just type what I see. Negative x squared plus 2x plus 1. And then we want to graph. See whatever we see. All right, so on this one, I can tell that it looks like the vertex is at 1, 2. I might just confirm by looking at my table. Confirm that it does go through 1, 2. And there you can see that it does. Okay, and notice the symmetry on both sides of that point, right? So that's what you kind of want to see. So vertex, again, is at 1, 2. I'll go ahead and plot that point. And then my axis of symmetry, remember that's always x equals the x coordinate of my vertex, right? So x equals 1. That's the equation for this line. The domain. Well, I guess before we do that, before we answer these questions, I'll go ahead and fill in the rest. So again, we have a point here at the vertex, and then I'm just looking at my other ordered pairs. So it says 0, 1. It says 2, 1. And then, like on MathXL, this would have finished it for you after these 2 points. I like you on paper to put 5 points, so I'll go ahead and include -1, -2. And 3, -2. All right, now we have a really nice, accurate, some really nice, accurate guide points. We could go further if we wanted to, but that should be plenty. Domain, you don't even have to think about it. That's always going to be all real numbers. There are different ways to say that, but I think on MathXL, that's what it wants, all real numbers. The range is where you have to think just a little bit. It's always going to be y is less than or equal to, or y is greater than or equal to. In this case, it's going to be less than or equal to because my function, that's as high as it goes. So it's going to be less than or equal to however high it goes, which happens to be the y coordinate of my vertex. So y is less than or equal to 2 in this case. Is that value a minimum or maximum? Well, if it says all y's are less than or equal to 2, then that must mean it's the maximum value. If it turns downward, it's a maximum value. If it turns upward, it's a minimum value. And then the value is 2. All right, so that's basically it. Lean on that graphing calculator. And another tip, I would say, if you get a weird one that you type it in and it's off your screen, you can always zoom out, but Desmos might be more user-friendly as far as the zooming in and zooming out goes. So sometimes you may have to use Desmos to find that initial vertex visually. On that note, we'll get to how to find that algebraically. Okay, so this problem is about find the vertex, the axis of symmetry, minimum, maximum, and domain and range, kind of without really graphing. So it's the same problem. So we're going to have the same solutions, but I'm going to show you how to find those algebraically. All right, so if I were graphing this by hand, the first thing I would want to find is the axis of symmetry. Really, this is the biggest thing you need to take from this example. All right, so the axis of symmetry is going to be this formula right here. That's going to end up being pretty important. That says x equals negative b over 2a. All right, x equals negative b over 2a. So I'm going to sub in what I have. X equals negative, that's built in, b is 2 over 2 times a, so a is negative 1, so 2 times negative 1. When we simplify, I know I'm going to have a double negative there, so it's going to be positive, so it's 2 over 2, so that gives me 1. X equals 1. If we go back, or if we look at our graphing calculator, we can see that is correct. That's the axis of symmetry, x equals 1. After that, we can use that to find, the next couple of values, right? Next, we'd want to find the vertex. So we already know this. We already know if that's my axis of symmetry, then my vertex goes through the point 1 comma something, right? The idea is how do we find the y value? Well, we can always sub in an x value to get a y value. So that would just be y equals negative 1 squared plus 2 times 1 plus 1. So if I just punch that in real quick, negative, I'm going to use parentheses there just to be extra careful with my calculator. It's easy to mess up if there's a negative or positive base. Just be careful, plus 2 times 1 plus 1 is 2. So that tells me that 1 goes to 2. So my vertex, which we already knew, is at 1, 2. I'm just showing you how to find it algebraically, aka without a graph. So how would we know if it's a minimum or maximum? Well, we would look at, does it turn up or does it turn down? That tells me that it turns down. The fact that it's negative is what I'm referring to. So if it turns down, it's always going to be a max. So I'm going to go ahead and say the maximum value equals 2. And then you could do your domain and range as well. Domain, we just know, is going to be all real numbers. And range is going to be let that catch up for a second. Range is going to be y is either greater than or equal to or less than or equal to 2. So then you got to think, if 2 is my maximum value, then all the other ones would have to be less than. So less than or equal to 2. I don't advise you trying to do all that algebraically, but it's nice to know, at least, like I said, this is helpful, knowing how to find the axis of symmetry, especially if you graphed one whose axis of symmetry was like, 1.5 comma 3. That's going to be hard to come up with just by looking at your graphing calculator. Right, so let me just do one of the next two, and I'll let you look at the other one on the notes, and then that'll be it. So directions here are just to graph it. It says use a T-chart, and I'll fill in the T-chart, but really that's just your table on your graphing calculator. Okay, so if we want to graph y equals 2x squared minus 8x plus 2, hopefully some things you notice right off the bat. It's going to open up because a is positive, and it's going to be vertically stretched by a factor of 2. Those are things you need to start to notice as we go before we even punch it into our calculator. So on that note, I'm punching it in 2x squared minus 8x plus 1. Go ahead and look at my graph just to kind of see where the vertex is. So kind of hard to tell, but it looks like it's at 2 comma something. So let's go ahead and go to the table to just confirm. It looks like it's at 2, -7, right? And I can see that symmetry on the other side of that, so I know that is my vertex. I'm going to go ahead and plot that. Actually, let me just copy this table while I'm here. So we had 2, -7. You want that to go in the middle. And then I'm going to copy from here down. 0 goes to 1, and I'm just copying off my table. 1 goes to -5. 2 goes to -7. We already have that. 3 goes to -5. And 4 goes to 1. So a question you might have is, how did you know to plug in 0, 1, 2, 3, 4 or copy that part of the table? And the answer is because your vertex should go there. That'll give you a good picture of where everything else is. All right, so vertex is 2, -7. That means my axis of symmetry is x equals 2. This one asked me about a y-intercept, right? So remember that is where it crosses the y-axis, so 0, 1. The domain is always going to be all real numbers. Don't have to think about that part. And let me put this on the graph and we'll answer the next two. I like having a visual before I do range and minimum and maximum and stuff. So 2, -7. Right there. And then looks like 1, -5. 3, -5. And then we have 0 goes to 1. And 4 goes to 1. Let those all pop up here in a second. Give it just a second to catch up here. While we're waiting, I'll go back to my graph. There it is. Just to see that it does kind of match up what we put on there. I'm gonna go ahead and also draw my axis of symmetry as well. So that's x equals 2. And then I'm going to go ahead and just make it look like a continuous function. Kind of connect the dots. All right, so my range is going to be, it looks like y values that are greater than or equal to, because this one turns up, whatever my y coordinate is there, which is -7. So that makes -7 a minimum value. I'm just going to circle the word minimum. And the value of the minimum value is -7. That's the lowest number that this function produces. It's the lowest output that any input could produce, in other words. Okay. Example 3, I'll leave to you to look up on the notes. And then our last example says, which is the graph of -3x squared minus 4x plus 6? So a couple of things that we could look at. Well, okay. I was going to say process of elimination. I can tell it turns down. I can also tell that the y-intercept is going to be 0, 6. But that one looks like it goes through 1, 2, 3, 4. Well, maybe it doesn't go through 0, 6. I can't really tell. Let me zoom in. If we can use process of elimination, we'll answer it without looking at our graphing calculator. So again, a couple things that I'm looking at here, and we'll see if I'm correct, is I know it opens down. So that eliminates this guy. Okay, I can also tell that since my constant is 6, I can also tell that my y-intercept, you want to be careful calling it b here, is 0, 6. Let's see, that's 1, 2, 3, 4, 5. Okay, it does look like that goes through 0, 6. 1, 2, 3, 4, 5. So those both go through 0, 6. So we don't have enough information here just to answer it. So let's go ahead and just punch it in and see what's what. We could get fancy and find the axis of symmetry, but let's just go ahead and punch it in and do it the easy way. So negative 3x squared minus 4x plus 6. And so it's going to be this one right here based on what we see on our screen there. Okay. And again, like I said, we could have actually solved that algebraically if we said, what's the axis of symmetry? So that would be that would be x equals negative b, so negative 4 over 2 times a, which is negative 3. Give it a second to catch up. So count up your negatives, 1, 2, 3. It's going to be negative something. And you got 4 over 6, so negative 2/3. All right, that would have told me that it can't be this one because that one has an axis of symmetry of x equals 0. This one has negative something, right? So that would have been the one that made sense. Like I said, that's more than you really needed to know. All you needed was to punch it into your graphing calculator, and that would have been the easy way. Anyways, that's that. Your homework to go along with this will, of course, be a Math Excel section 4.2. Hopefully this video is helpful. You guys ask questions if you need, and this is all really important stuff. So make sure you're staying on the ball, asking questions when you need to. Thanks. Have a good one.